The next problem based on law of gravitation is what happens to the force between two objects if the mass of one object is doubled, the distance between the objects is doubled and tripled, and if the masses of both objects are doubled. So we have separately written the three statements, the three conditions. So let us start with the first condition. What happens to the force between the two objects? So first of all, write down the formula for force between the two objects, which is we have considered the original case, that is case 1, that is F1 is equal to G into M upon D square if the mass of one object is double. Now the second case is mass of any one object is double. So let's say the mass of first object is double, that means now the mass, instead of capital M, we have to write twice M because the mass is double. So this is F2 is equal to G into twice M into M upon D square. So this F2 is equal to, we can write as 2 into G into M upon D square, and this complete is F1. So this is F2 is equal to twice F1. So when the mass of any one object is doubled, the force, if the mass of any one object is doubled, the force between the objects, the force between the objects becomes twice that of the original force. Okay, now the second condition, what happens to the force between two objects if the distance between the objects is doubled and tripled. So first of all, we will see this, what happens when the distance is doubled. So same as that in first condition, we will write case 1, case 2. Case 1 is the original case where F1 is equal to G into M upon D square. This is the original statement, mathematical form of original statement of universal law of gravitation. And in second case, we will consider the condition given in the problem. So if the distance is doubled, the force will become F2 is equal to G into M upon, instead of this D we will write twice D. So twice D ka square. So this F2 is equal to G into M upon solving this, squaring this, we have 4 into D square, and this is equal to 1 by 4 into G into M upon D square, and this is 1 by 4 into this complete is F1. So this F2 will be 1/4 of F1. So and in this problem there is another case, which is case 3, that is if the distance is tripled. If the distance is tripled, that means 3 times the original distance. Now in this case, the F3 will be equal to G into M upon 3 times D square, which is equal to G into M upon squaring this, we have 9 D square, so which is equal to 1 by 9 into G into M upon D square, and this is equal to, this F3 is equals to 1 by 9 into F1. So if the distance is tripled, then the force will be 1/9 times that of original force. As there is lack of space, I have not written in words. Okay, now in the third condition we have to find what happens to the force between two objects if the masses of both objects are doubled. Okay, so if the same as we have seen in the first two conditions, the first case is original force, which is F1 is equal to G into M upon D square, and case 2 is as per the condition given in the problem. So the masses of both objects are doubled. So mass 1 will be doubled, mass 2 will be doubled. Sorry, this is small m. So now the force F2 here will be equal to G into twice m upon D square. Solving this, we have this 2 into 2 get multiplied, we will get this 4 into G into M upon D square, and this complete is F1. So this F2 is equals to 4 times F1. So if both the masses are double, if both the masses are doubled, then the force becomes 4 times that of the original force. Okay, that's it. This is the answer.